Hi everyone, I've got a bit of news today. What I've got here on my desk is a 4x4 backpack. I have been using it for quite some time with the Nordic Power Profiler. The Power Profiler measures current consumption, and that helps a lot when working on power optimization. I can test changes in the code and their impact on whether we improve power usage or not. I have a different video on that. Let me first show you this keyboard and open it up. It's a pretty useful test keyboard since it can be easily disassembled. This is the 4x4 backpack, and this is the 4x4 keyboard. More on that one later. Now on to the news. I have developed a brand new 4x4 platform. It's identical to the 4x4 backpack, except for a few things. One, it has a LiPo battery and a charger on board. To be able to charge the battery, I need a USB connection. Since we now have a USB port on board, I also included a serial chip. Now we can program the nRF52 using serial without having to worry about connecting any wires. It's quite useful for firmware development and testing. When we consider these two boards, we have two types of batteries. One uses a CR2032, a non-rechargeable 3-volt battery, which is essentially directly connected to the nRF52. Here we have a rechargeable battery, which goes through a 3.3 volt regulator. In order to measure the battery voltage, we need to go through a voltage divider and measure that off of a ADC pin on the nRF52. To measure how much battery life there's left, the battery service needs to be able to handle both configurations. With these two boards, I will be able to develop the BLE service to handle both types of batteries. Other features that are included are things that are a little bit more colorful. If I press the reset button here, there are two status LEDs showing up. These are the same as those on the Adafruit Feather. There are also a couple of white LEDs on the ends, and these are pulse width modulated, yes, through a MOSFET transistor here. This is the same way that we actually implement the under key LEDs on the Luddite board. If I wake it up, you'll see it all lights up. In addition, we also have a WS2812B on board. This is a single programmable RGB LED. Yes, RGB. They can be programmed using the NeoPixel library from Adafruit. I've tried it, it works. This means that with two boards, one can program a lot of the features that a modern Bluetooth keyboard needs. Battery service for indicating battery level for both non-rechargeable and rechargeable batteries. Status LEDs to indicate paired and connected status. RGB LEDs for board underglow. Pulse width modulation for key underglow. Everything is right on here on two boards to be able to develop and test with. You can see if I just wake it up, it wakes up, it brightens up and dims out to save battery after some time. If I just go and press and keep typing, the LEDs stay lit and then dims after a brief amount of time. This is just one method of modulating the brightness of the LEDs. With a platform like this, it's pretty easy to add multiple methods of modulating the LEDs. With a set of two platforms, one would be able to have communications between the boards and coordinate layers, LEDs, and RGB. When we type, key backlight, keyboard underglow could all react to key presses, layer changes on both boards. From a split keyboard firmware dev point of view, This is a type of advanced and more colorful feature that are possible to experiment with and develop with a pair of platforms without having to commit your daily driver. So, why the 4x4? This is a keyboard that was already designed by 40% Club. We have this simple 4x4 matrix with a footprint for the Arduino macro. This is an unconventional Arduino to use for custom boards. However, with these you can connect multiple 4x4 together to get a 4x4, a 4x8, a 4x12, all the way up to a 4x16 keyboard. This modularity allows for test keyboards of different form factors. It's a very useful platform, modular keyboard that allows to go from a single macro pad all the way up to a, full-size keyboard. This is essentially what I've been working on over the last few days. It's getting this platform out and working. I'll be working a lot with this platform for the future of the firmware. And this is always compatible with the BlueMicro hardware.